Hi guys, today we're going to talk about graphing logarithms. Here you see a picture of two functions. This blue one here is an exponential function that we've already talked about, and then we are going to explain or talk about logarithms, which is the red function here. So let me just give you the function that I'm using. I have f of x equals 2 to the x power. That exponential function, it is a growth function here. The b is greater than 1. Let's talk about the domain. The domain, remember, those are your x values. So as you move to the left and to the right, you want to think, is there anything that's left out? Are there any numbers that we can't use? So as we travel to the left, remember on your x values, as you travel to the left, going more negative, there's an arrow there saying it can go on forever and ever. And as you travel to the right, well, this graph, this part here, continues to get wider and wider as you move to the right. So we can use all real numbers. So here I'm going to put all real numbers. You could also put from negative infinity to positive infinity in your parentheses. And then the range. The range remembers your y values. So the range here, well, we never touch 0, but we get really, really close to 0. So we're going to say from 0 to infinity, or y such that y is greater than 0. We cannot say equal to because we never land on 0. So y such that y is greater than 0. All right? And the asymptote here, well, the asymptote is this line right here, which is the x-axis, but we need to write any asymptote, because it's a line, you write the equation of the line. So the equation of the x-axis is y equals 0. Okay, I'm going to switch to red now, and let's talk about the red function. Okay, this is actually the inverse, you can tell because it's reflected over the line y equals x, and this is f of x equals log base 2 of x. All right, the domain here, well, can I use all of the x values? I can tell that I'm going far, far, far to the right, but right here I start going closer and closer to this y-axis. So I'm not going to cross over this y-axis because I'm just getting really, really close to it. So on my x-axis, I'm not using any negative numbers, and I don't even use 0. So for my domain here, we'll say the set of x such that x is greater than 0. Now, recall back, sorry, that looks funny there. Recall back to when we talked about inverse functions and their domain and range flipped. Okay, so if you take a look here, the y was greater than 0 for our exponential function, and our domain, so the range is now the domain, so our x is greater than 0. And hopefully you'll recognize now that if that's the case, then the domain here for exponential functions is now the range. But just to double check, the range is your y values. Okay, so we're looking at how low will it go or how high will it go, and is there anything missing as far as y's go. And if we look down, it goes down, 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 down. It'd keep going down forever and ever, so we can use all of the negative numbers. And then we come up and we're going up, 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 and it's going to continue to grow as it moves. As the x values increase, it will continue to grow up. So we can go on forever and ever upwards. So we'll say all real numbers. And the asymptote now, follow this line right here, this curve. Follow this curve, and it gets really, really close. The asymptote is your y-axis. Okay, so your y-axis, if you wanted to write the equation of this asymptote, it's x equals 0. Okay, so let's move on. Let's actually graph one and see how it works. So we have an exponential function 3 to the x power. I'm going to use my blue and my red. So if this is x, this will be f of x. F of x is the same as saying y. I'm going to plug in my x values that I'm given. negative 2, negative 1, 0, 1, and 2. And then when I plug these into the calculator, well, I'm just going to write them, maybe I can get them down here. So for 3 to the x, if I plug in 3 to the negative 2, that is, remember the negative says flip the base over, so 1 over 3, and it's squared. So this is 1/9. 1/9. That should be an arrow there. So we have 1/9. Okay. If I have 3 to the negative 1, that'll be 1 over 3 to the first power, which is just 1/3. At 0, any number to the 0 power is 1. 3 to the first power is 3. And 3 squared is 9. So I'm going to graph that. At negative 2, I'm at 1/9. 1/9 is really, really, really close to 0. Negative 1, I'm at 1/3, still really close to 0, but just a little bit higher. 0, I'm at 1, that's here. At 1, I'm at 3. And at 2, I'm at 9. Okay, so I'm going to try to draw this as best I can. Now, hopefully yours can be sketched a little better. All right, so that is the exponential function, and we're really more concerned about the logarithmic function. Now, as you've learned already, that logarithms are the inverses of exponentials. So, in the last video, you talked about how you could graph inverses, and all we did was switch the x and the y's. So that's what we're going to do here. The new x will be whatever the y value was, and the new y, which is the inverse, will be the old x. So just switch places. So we've got 1/9 and negative 2, 1/3 and negative 1, 1 and 0, 3 and 1, 9 and 2. Okay, and we're going to graph these points. So 1/9 on the x-axis, 1/9 is really close to 0. We'll be down at negative 2. Oh, I should change colors. All of these should have been in red. Okay, so maybe if you're doing different colors for your graphs, change those to red. All right, so we're going to be here. And then at 1/3, we're at negative 1. Okay. At 1, we're at 0. At 3, we're at 1. And at 9, we're at 2. And then we'll try to sketch this. That should be a little better there. Make sure you put arrows on both ends. Now your calculator, when you go to graph logarithms, your calculator will not show you. It'll stop right in here. But you have to know that if you keep changing the value, you like I could put in 0.1, 0.01, 0.125. I could put any of those values in there, 0.00025, and get really, really, really close to this y-axis. So just like I could get really, really close to the x-axis, the same thing occurs here. But your calculator does not show you that. So make sure that you put an arrow here. It does not just stop. Okay, so in class we're going to do a few more problems, and you're going to graph these logarithms. Just make sure that you realize that when you are graphing, let me get a line here, hang on. Just make sure that when you are graphing, if you graph a function and its inverse, it should reflect over the line y equals x. And you notice that these two are reflecting over the line y equals x. All right, let me know if you have any questions. Bye.